Can you guys hear me? Someone is saying there's no sound. Eric is saying there's no sound. Yes, you can hear me. Eric, you just need to refresh and thank you, Eric. Very clear. Thank you, Eric. Okay. So the session is being recorded. Yeah, it's recording. It's recording. Which application am I using to record? In Zoom, we have internal recorder. Here, you just click record. In Zoom, we have that inbuilt recorder. But also, in case you guys want to record tutorials, you want to record something on the screen, you have this extension. It's called Apex. I use this Apex to record my screen. It's just a small recording here. Yeah, you can use this Apex based screen recorder. In case you guys want to record your screen on something small, yeah, just use Apex. Apex screen recorder is an extension that you install to your browser, and it will record your entire screen or your entire machine. Yeah. Apex, yeah, it's Apex. Melon, it's Apex. So let's get started with OP. What is OP and why OP? OP is object-oriented programming. Object-oriented programming. Remember in the first days we said Python is English-like language. So every word is curated carefully. What is an object? A car can be an object. House can be an object. A person can be an object. A car can be an object. Anything can be an object, or anything is an object. So I just want us to read through all this. Imagine everything is an object. A car, a book, or even a cute puppy is an object. Anything can be an object. So OP helps us model complex system by treating real-world entities as object within a program. So OP basically helps us model complex systems by treating real-world entities as objects within a program. So we assign them classes or blueprints and attributes or their characters and methods as their actions. So when we say we assign objects or parts of programs or parts of software as classes, as attributes, or as characters, remember what we said OP is just an object. A car has blueprint, the design of the car. Car has attributes, the characteristics of that car. What can car do? A car can jump, a car can do all those kind of things. Can topple, can spin, can drift, can do anything, a car. Those are characteristics. Then we have methods, their action. It's moving, a car is moving. So that's the action or methods. So that's what basically OP is. We treat everything in a program as an object. We said examples of objects can be a car. A car is an object. A book is an object. A puppy is an object. A house is an object. A person is an object. So you as a person, you have your characteristics. What are some of the characteristics of a human being? They have age, they can speak, they can move, you can read and write. So those are some of the characteristics of a human being. So let's assume we want to simulate that into a program. We write as a person, as a class. So a class, we can define it, for example, as the name of that person. Joroge is a class. Joroge is 8 years old. Joroge can run, can read and write. But we know those are the characteristics of Njoroge. But when Njoroge is writing, when he's speaking, when he's reading, are the methods or the actions. I think that example makes sense. So you have to treat OP or objects just like that. So in programming, when we talk about class, class is a blueprint or prototype, like a recipe or recipe. So defines the structure for creating object. A class defines the structure of creating objects. And what is an object? An object is a specific instance of a class. Think of it like a cake made from the recipe. So we have the recipe or the recipe, depends with how you pronounce it. So the same. So we have the class, we know we want to cook a cake, but we have the properties of that cake. It's an object. Then attributes are the characteristics or properties of the object. So what is the attribute of a cake? A cake has a color, type, and all those, the taste, all those kind of things. It's vanilla, it's whatever, it's chocolate. Yeah. So those are characteristics of the cake. Methods, actions or behaviors that an object can perform. A car can drive, a car can move, a car can stop. All those are characteristics of a all key concepts that you need to know when it comes to OP in Python or OP in general. So there is this example here. I will explain further. So there's this example here where we have a class and we have car. We said the class is the blueprint or the prototype, or that defines the structure for creating the object. So we use the keyword class, then we give the name. So this can be class person. A car class has color, okay? And the color of that car is red. The color for the car is red. That one is the attribute. And we said attributes are the characteristics or properties of an object. Okay? Then the method, we said they are the actions. The methods are the actions. Then a car can drive. A car can drive and a car can stop. Back to our definition here. Back to our definition of this so that we understand the example. OP helps us to model complex systems. OP helps us to model complex systems by treating them as real-world entities. Again, so that we understand this example. I know OP sometimes seems to be a complicated topic. So that's why we are going back and forth. So OP helps us model complex system by creating real-world entities as objects within a program. So we try our best to simulate all these real-world objects into systems. So let's assume that you want to simulate a car into a system or into software. So we define the class car, we give the properties, then we give the action for that car. Have we simulated our car? Of course, yes. You have coded a car with the class. You have given it properties as much as you want. Those are the attributes. Then we gave it a method. That is the action. So we want our car to drive. So that's an example. I don't know if you guys know that OP writing something like this is just like writing a simple function. You can either write a normal function that you use define or the def char as a function, or you can use another form of writing the function is by writing OP. Okay, so let's write this example in our code so that we try and understand, and we show you the difference between object OP and normal functions. So this one I'm going to call it class.py. So in this example, what we are going to do is, just a minute. So we call it class car, and car, the word car, should start with a capital letter. That's the function. That's how you can write a car. Okay? That's how you can write a class. A car has property that is color of red. Okay? We can use the model as BMW. You can write as many properties as you want. And over here, we can try to pass the method. So this method will be used to display the car details. Okay? So we can write a function like car drive. I'm going to explain some of these concepts. And say print the car is driving. We're going to explain this. So let's just write the example, then explain what's happening. So once we write this, what we can do is we can assign my car, my underscore car is equal to the car. Okay? A car dot drive. Then over here we can print my car dot color. So I want to explain this example right here from top to bottom. Let me zoom, hide, and zoom like this. So we said this one is just like writing a normal function. When you think of OP, think of a normal function. Like for example, let's assume this was a normal function. Let's assume we are writing this as a normal function. So OP is just like another way of writing functions. Just like another way of writing functions. We say this is a car, and this is the class, or the blueprint of that particular class or program. Then we said we pass properties, okay, or the attributes. We call them the attributes. So a car has a color, red, and we have the model, BMW. So in that case, we write a method to display car details. So method is the behavior. Method is the behavior. Methods, or we can turn this to be behavior of that particular car. Methods or behavior to display the car. So we define a function of drive. Then we print the car is driving. Now assume that we want to execute this program. Assume now that we have written up to there and we want to execute this program. So in a normal way, if we were writing this function, this is what we could have done. Let's assume we are calling this function. We could just say drive like this. If we were writing a normal function, we write a function, then we call it this way, okay? So in that case, instead of writing that in OP, we can take a variable that we can assign it to this function. I said we treat these ones as functions. So we assign this class here. Just treat it as a normal function. So we take my variable or my car, we assign it to this one here. Now, because we have assigned my car, we can say my car dot drive. Okay. Now we call this function here inside my car. So we took my car variable and we assigned it to this class or this function. Just treat OP as another way of writing a function. So I'm going to use the two words. I'm going to interchange the two words. So in case you hear any of them, just know we are referring almost to the same thing. It's just another way of doing it. So we take my car variable, we assign it to this class or this function. Okay. Now, remember that inside our car we have some few methods, properties, and the rest. Assume that I wanted to call this function. What could I have done? I take my car that I've assigned to this, then I call the function that I want to execute. Then we call the car drive. Then I can also print my car dot color. For now, I want to comment this code. Let me just comment this code and run my code and see the output. The output will dictate whatever we are doing. Week. Let me change CD to week. Week 5. Let me rerun the code. My car dot drive. Okay. Okay, let me run this car and see. No problem so far. Then I uncomment this, run my code, my car dot red. So far, let's first remove this. Let's first remove that so that we understand our example. So before we include the code that we just removed, this is what is happening here. So remember, this is a function or this class, and we are trying to call it here. So I can print my car dot color. So what am I doing here? I'm going inside this function or this class, then I'm printing whatever I wanted to print. So it's my car is red, or I can also print the model. Instead of the color, I can print out the model, just like that. And if we run our code, we can see the color model is Beamer, it's BMW. So that's basically what this code is doing. So back to our example here. Back to our example here. So I want us to see something. The example that we just removed here. Where is it? This car, my car dot drive. So if I run this code, our code has failed. But if I introduce something here, we are calling it self. We are calling it self and run our code. You can see the car is driving. So I want us to see something here that happened. So if we remove, we know this is a normal function that should not have parameters and the rest. It's just a normal function. But if we try to call this function, and this function, of course, it's inside this class. If we try to call this function in a normal way that we are used to calling functions, our function fails. We have an error, and it's telling us It takes potential argument, but it was given none. So if we use the keyword self and rerun our code, the car is driving. Our code executes correctly. So anyone with an idea what this self is doing? Before I explain, anyone with an idea of what that self is doing? Yeah, anyone with an idea what that self is doing? Millicent, you are saying it's making the car drive. You are saying we are fueling the car. Millicent is saying the self is like it's like a petrol, it's like diesel. We are fueling the car. It's calling itself. It's a parameter. It refers to the car, making the scope global. Let me see. You are. It's like a parameter or an argument calls the object. Its ownership, enabling the function to be called, refers to the class, used to access the multiple instances, refers to the instance of the class, and wow, this is what I was looking for, this example here. Let me just copy this so that we explain. Let me see. Self is a reference of the current instance of a class, allowing you to access and modify its attributes methods within the definition. Let me see. People are commenting with the car red, blue, red, blue, red, blue. Wow, this is awesome. Okay, I'm going to copy these two answers. We have, I was looking the one with the correct definition. How do you comment? Alt Z to fold. Yeah. So these two answers that we have been given, they are the correct answer. All these answers are correct. So the self here, the keyword self. So in Python, we said we have keywords. Or in any programming, we have keywords. Self, it's a keyword. You can't just use any other word like myself. Let me see. The car is driving. Yeah, this is awesome. So yeah, you see this, anything that I write here like self, myself. So self is just like a pointer. Self is just like a pointer, which refers to the instance of the class the method is in. Another definition refers to the instance of the class, and it's used to access attributes or methods within the class. So for us to access this function, we have to add this parameter. I said OP is just like another way of writing functions. How do you write a function? A function has parameters and arguments. For now, before we go further, before we dig deeper into OP, first treat this one as a parameter. Even if you place cursor, when you place cursor right here, you see that self is a parameter. Okay, but what does it mean? For this function to be called, remember this is a method. So for this function to be called, that is inside our class, we need to pass a parameter right here. So this parameter basically helps us to refer to the instance of that particular class. So that's basically how this does. That's just an example of how that really works. So all those comments were correct. So Richard is saying it's a reference to the current instance of the class. It allows you to access variables and methods that belong to the class. It allows you to access variables and methods that belong to the class instance. So this one is a very good example here, a very good definition. So the self, or this parameter that we are passing into our function right here, it will allow us to access this particular method or this particular behavior that is inside our class. If we don't have these parameters right here, that means we are unable to access, or we are unable to use this particular method or this particular function inside our particular class. That's simple definition, and that's a correct definition of this self. So when writing these classes or P, remember always to have, or in your methods, remember always to have a parameter self that will clearly help you or enable you to access these methods that are inside these, or they are instances of these classes. So as we said, Python is just like English like language. I'm going to be using two different terms in every example. So we say the class, when you're treating OP, treat it like a normal function. In your mind, it's just a normal function. So just treat it as a normal function, okay? And in function, we can have all these kind of things. But because now it's a class, it's an OP based, that means in every function or in every method that we are going to write, we have to add this parameter. In this parameter, it will help us be able to access any instance or any method inside our class. Okay, can you have more than one method within one class? Yeah, we can have more than one method. So what you're trying to mean here is, can you have more than one method here? The car is driving, of course. Can we add one more example here? The car can drive and the car can stop. More than one method. And the car has stopped. As simple as that. You can have as many methods inside a class. Very simple. And of course, if we have done car can drive, we can add a car, my car dot stop. My car dot stop. When we run our code, the car is driving, the car has stopped. Yeah, we can have as many methods as possible. Yeah, we are going to explain. We are going to see. We are going to see how to define the init function. We are going there, Innocent. We are going there. So that leads us to the next topic. This is just an example of creating your first class. Now, what if we take it a little bit further complex, or we try to make it complex? What if we try to make it more complex? That's where constructors come into play. What are constructors? For example, you notice the init. So what is a constructor? A constructor, example, every time you create a new object, You want it to have its unique attributes. Color model etc. So constructors, or the use of the init constructor, it's a keyword, it's a key inbuilt function, or the init method allows each object to start with specific values. Example, it's just like building a pizza within with the toppings you want. We are going to explain this example again. So what is a constructor? A constructor, every time you want to create a new object, every time you want to create a new object, you want it to have its unique attributes, color, model, etc. So by the use of the init method, allows each object to start with all specific values. Someone is asking, we are going deeper, but what's an object? Let's go back to our first here. What is an object? An object is a specific instance of a class. Think of a cake just like that, a method. An object is a specific instance of a class. Think of it as a cake made from a recipe. Okay, so that's what we call by instances. An example so that we understand these examples. So we define a car class, then we can define with the instance or with the constructor init using the init method. So we define color and model. Self.color, then self.model. We are going to see this example and explain what this big boy is doing. So let's just write that example so that we see what we mean. So let me just write another example here. We write class. Nope. We write class person. Maybe we have a person. We give an example of a car. Let's give another example of a person so that we understand what are constructors. So here, let me do away with this. So constructors or constructor method to initialize the object. So we define it's double underscore in it. It's double underscore, then double underscore. That's how you write this init method. So that's how you write this init method. It's a double underscore. It's not a single underscore. When I do init single underscore or one underscore, you can see there are some errors. So it's a double underscore in the start and double underscore right there. Okay. Then we pass the self. Then we can pass, for example, name. For example, name, then comma, age. Close. So let me explain. Before I explain, let's just complete this example so that we explain what's happening here. So that I explain, let me just write a normal function. My person, let me just write a normal function and explain what's happening here. Let me just write a normal function. A normal function. That's like this. Normal function, person name, just like this. So I want us to see the difference between the two. You see here, this is a class of a person, right? We define it with the constructor. And we use the init method. We pass the self so that it's a parameter that helps us access instances of this class. Or this self will help us access this function when we are trying to execute this function. So we take self, we pass the name and the age as parameters. So what are we doing here? In a normal function, this is how you could interpret it. You write a normal function, name and age as normal parameters. Then we take the person name, we assign it to this name. Age, we assign it to, for example, person age is equal to age. Then print, I just want to print out these examples here. I just want to print these examples. How do you do it? Let me just call the function first. Define my person. Oops. So what's missing here? Yeah. Now, this function is just like this. I want to show you the difference between this function and this one here. So in a normal function, this is what we could have done. Name, age. Person name is that person name. Person age is that person age. For example, I've not added this. So if we were trying to print out this normal function, we could assign this name to Evans, age to 20. This example is not the perfect example, but let me show you the difference between this and this one right here. Now, we can write another method here, define let's say person details is equal to self, then just like this. Let me show you the example here. So you see this, you see this, you see this. So we define a class person, okay, with the constructor self and age, name and age. So we take self dot name. So we take self helps us access instances of this class. So we want to access the name. So we take the self dot name. Okay, sorry for that. Okay, let me go back to this example here. So we said self will help us access all the instances of this class person. Okay, so we have the self dot name in which we assign to the actual name. age the same way. So let me just comment this and see if we are going to show any output or we have any errors. We have any errors. So instead of writing that, I can use the return. I can use the return instead of print. No output yet. No output yet. Let me do away with this. So basically, this is how we write all these instances of a class. So let's just go back to the content and we see what this example has to do right here. Okay. So in this example right here, we just wrote all the way up to here. So let me, no, we don't need this. We don't need this actually. Actually, we don't need this. I can basically say person details are just like this. Example is just like this. Just like this. Yeah. So you see this class here. We wrote a constructor in it with a self. That will help us access these instances of this class. So self.name, we assign it to the name. The age, we assign it to self.age. So we define another variable name, person details, in which is person, and the function is John and 30. So name goes to name, age goes to 30. So we said in a previous example when we are learning functions, we said name is equal to John and age is equal to 30. So this is just the same way. It's just the same way. Take a variable, assign it to a value. Take a variable that is parameter, assign it to a value, the attribute. Take the age, assign it to 30. Take the age, assign it to 30. The same way. Nothing has changed. Just the same way. It's just a different way of writing this. So basically, that's what it does. Now we can print person details, the variable dot name. We can now access the name. We can now access the name. And you see the name is John. If we try to change this from name to age, that means we can print out age, which age is 30. With that example, let me just go back to the definition and explanation so that we understand why now. A constructor, every time you want to create a new object, every time you want to create a new object, you want it to have its unique attributes, color, model. We use the constructor init that allows you the object to start with specific values. So this constructor here, this constructor right here, all these attributes here, all these instances, they belong to this. They can't be assigned to a different constructor. So now these ones, they belong to that. It's just like creating a sense of belonging. This belongs to me. This really belongs to me. It's just like creating that sense of belonging. That's what the definition says here. Every time you want to create a new object, you want it to have its unique attributes, unique sense of belonging, like color, model. So we use the init constructor or init method that allows each object to start with specific values. So this one belongs to us. This one belongs to me. So the init method, creating the sense of belonging. This one belongs to me. Uniqueness, creating unique attributes for each particular method. I said with the previous example, um, I can see you guys are debating about Copilot. Copilot is good. Copilot is good, but as you can see, still annoying me. It's still annoying me. It's giving me suggestions, but I'm not there. While learning, it's bad. While building, it's the best. So, I want us now to know the difference between OP and normal functions. When writing a normal function, in some case, and we are trying to build a complex system, in some cases, you might write a function, exact function name, exact function attributes, variables, and characteristics of a function. Already you have built the first function, but in another way, we can build the same by mistake if we are using a normal function. But OP will help us now avoid that. It will help us avoid that. Why? If I create this class person and I use a constructor, it creates some sense of belonging. This one belongs to these particular instances of this class. If I create something else, I define almost similar variables or instances. Then I use the init constructor. Then that other example will create the sense of belonging or ownership or uniqueness to that new class that we have or methods instances that we just created. So that means if we were creating a good function that was working, and then by mistake we create another one, that one won't interrupt the other one. So functions will still be working. Example, in real world application, how is that used? For example, you are creating a software. You are creating a software. Can you add more person details? Yeah, you can add more person details. You can add as many person details here, like height, then you do the height here. Let me just, before I give that real world example, can you do that? Yeah, of course you can do this, you can do that, And we are facing an error. We are facing a very big error here. We are facing a very big error, in which it's a good one, in which it's a very good error that we are facing. So what error are we trying to get here? Person.init, missing one requirement, position, argument, height. Another good example of why we should use classes or why we should use OP. You see, we have these variables here, well defined and well assigned. But when calling our function, we only passed 2 arguments here, but we expected 1, 2, 3. So if we try to miss one, then our program will break. And now you see it's working. So that means in OP, it will help us avoid some silly mistakes. Like, I just created something. Why is it not displaying in my front end? Why is it not displaying? It will give you the error. The program is running correctly, but it's not displaying. Why is it not displaying? Then you get into that frustration and that error. So that means if we use OP, that means we can avoid some silly mistakes or some weird mistakes that we might make when writing our software. So that's a good example of a how to use OP. Oh, our OP is used to catch bugs, is used to make good programs. So another example is, let's assume that we are creating let's assume that we are creating a program like the LMS, okay? With time, our system will be more complex. With time, okay? Our system will be more complex. Now, assume that we are creating this function where we have the normal content, then we have the assignments, and we have the quiz. At some point, we'll have to link all these systems to work together, all these sub-functions to work together. Now, if we are using OP, we find the content is displaying correctly, the quiz, but the assignment has an error. So that means if you have an error in the assignment function, it will only interfere with functions, but will assignments, but it will keep all other processes running correctly. That's the advantage of using OP. So that's a good advantage of using OP in programming. Yes, we have advantages. Of course, we have disadvantages when working with OP. Let's assume that you have a very, very, very complex system. So because OP is trying to verify all these mistakes, at some point, your system will be slow. At some point, if you have not written your software well, at some point, it will be slow over using the normal functions. The normal functions, of course, a benchmark has been done so many times. A normal function, or it's called functional programming instead of object-oriented programming. It's functional programming. So in functional programming, where you're using the normal functions, that means your system will be fast. You won't have so many things to verify, like catching all these errors that we faced. It's just going to display. So at some point, if you have written your software well, that means when you are using the functional programming, it's going to display fast. Your system will be fast as compared to when using OP. But why use OP over functional programming? The reason is one, catching bugs, making sure your system is secure, it's safe. It catches all the necessary bugs on time when needed, and it avoids you having different all these silly mistakes. Okay, someone is saying, Kevin Onyanga, you are confused. Don't worry, don't worry. You are in the right track. You should be confused. You should be. It's day one of learning OP. Remember in the first days what we said. The first days of doing something, you'll be confused. And that's okay. That's perfect. You should be there. But with time, when you do something right, when you do day one, day two, day three, you are no longer the same person. You have learned all these things. I personally, day one of doing everything, I'm always confused and I'm okay with it. I know it's day one. I know it's round one. It's the first time. So, of course, I don't know. I'm going to be confused. But the catch is, don't give up. Don't give up. Don't give up. Don't leave. Don't leave. It's true. Yeah, Stacy, you are saying, yeah, it's true. It's true. Oh, I'm lying, guys. It's true. It's true. It's true. For the first time, you're going to be confused. It's totally okay. You're in the right track. You're in the right track. Then, the moment you do it the second time, very fine. The third time, very fine. That's what we said. We accept the reality. We accept the reality of things. No, we are not sugarcoating everything. Yeah, Faustin Kamau, I can say. Yeah, we should not be confused. We should know how to accept the reality of things. It's day one. You remember, let me take you back to day one when we are learning Python. Most of you are saying, I don't know how to run this code. No, I'm giving up. I'm leaving the session. But once we did it day two, day three, are you still giving up? Of course, no. No, 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 no. You didn't give up. We are here. Now you see we are learning new things. Remember, everything that you learn new, it's new. It's day one. You are going to have that. Yeah, so don't give up. Don't give up, Onyango. You're in the right track. But of course, let's enjoy. Okay, we are going to take, for those who are typing along, I'm going to leave this screen open for less than a minute as you digest this. Awesome, awesome, awesome. Yeah, someone saying they in class learning about classes. Oh wow. uh there's no way that you can run away from OP. So most of the interview sessions that you are going to be interviewed, most of the people will, or most of the interview questions will be two: data structures and algorithms, and basically something like OP. Most of the interview sessions that you are ever going to face. So there's no way you can avoid data structures and OP. Okay, so the last topic, let's try, because now the last topic, it's very simple because now we have done the examples. It's just the principles, the OP of principles and the examples. So the examples I'm going to leave you, we are just going to explain because it's all the same. So the same thing that we just wrote. Like for example, the first example we just wrote, it's nothing new. So what are OP principles? We have inheritance, we have polymorphism, we have encapsulation, and many more. So for now, we are going to do the three. So what is inheritance? Just like humans inherit traits from their parents, just like how you inherit traits, properties from your parents, that's the same way programming basically does. You inherit properties from an existing either class or something of the sort. So inheritance is just like how humans inherit traits from their parents. Classes can inherit attributes, methods from other classes. For example, here we define a class, vehicle, and we pass the methods right here. So this is a function by itself. Now you write another class of a car. Now we pass, instead of passing a single thing like wheels, we just take the whole function and we just pass it right here. Now, you see all these properties, everything inside this function has been inherited because we called it here, or we passed it here. It has been inherited right here inside this one here. So it's as simple as that. Just like how you inherit properties, just take it as that example. Write a function or this class, then you inherit that class here. So that means anything inside here has been inherited right here. The same way that we call the function, that's the same way that we call it right here. The next example, polymorphism. In this, I think we are going to write it. So what is polymorphism? Polymorphism is derived class, is a derived class. Can be or can behave differently from the same method inherited from the base class. Okay? So with polymorphism, a method name can mean different thing across multiple classes. So for example, imagine we have a class, we have a method speak, and we have a method bug, and we have a method meow for a car, for a cat. So this example will explain better. So we have the first class of a dog. A dog can woof. Okay? A dog can woof. We say this self will help us access these instances inside this class. Now, you define another class of a cat. Use the same keyword speak, in which that is the method speak, but inside the same program. A cat can meow. A dog can woof. A cat can meow. But this is speak and this is speak. Okay? In polymorphism, if you try to print out the two in one, like for a single animal in dog and cat, print animal can speak. So let's just copy and execute and see the output by ourselves. We can run this code so that we explain from the example. Woof and meow. So let's explain what's happening here. So we say a dog can wolf, but this one is speak. The same way we have a cat can speak. As you can see, we have the same key word or the same function name right here. It's the same, but with different attributes, but with different behaviors right here. Okay? Or with an expected different output. So if we print the two, we can see an animal, for an animal in this function dog, or in this class dog, and this function cat, we print animal dot speak. If we print animal dot speak for both, that means we get both outputs. That explains this word here. It's a derived classes. Polymorphism are derived classes that can behave differently from the same method inherited from the base class. They are behaving different. You have the dog and the cat. The same method, but they are behaving different. So that's what polymorphism basically does. So that's what polymorphism basically does, and that's all about polymorphism. That's all about polymorphism. As simple as it looks like. As simple as just it looks like. Yeah, I'm going to return the code. In case you want to access the code, it's already here in the LMS in week 5. The code is right here in the LMS in week 5. So we have, I can see my watch telling me we have a maximum of 10 minutes, max of 10 minutes. So what is encapsulation? Encapsulation, so this is the practice of keeping attributes and methods private to prevent unwanted interference from outside classes. So encapsulation is just like creating more privacy. So it's the practice of keeping attributes and methods private to prevent unwanted interference. So we don't want our attributes and methods to be interfered or to print almost similar results or to be modified anyhowly. Now we said, example, if we had a very complex system, if we had any complex system and we try to define almost similar things, okay, sorry for that interruption. So encapsulation, we said, is just like practice of keeping attributes and methods private to prevent unwanted interferences. So we define a class of secret stash. Of course, we use the constructor to create the sense of belonging. You remember when we said we use constructors to create that sense of belonging? This one belongs to me. There's no way you can use it. So use a constructor. So this one is a private attribute. That means it only just can't be used anyhow. It's private attribute, the chocolate. Okay? Before we continue there, let's just explore the code and see where these chocolates are coming from. So we define, take a chocolate. So if chocolates, you know these are many chocolates, greater than 0, then if we have like 10 chocolates, you can take one and you can eat one. So it's just like -1. You know chocolates are 10 and chocolates are greater than 0. So in that list of 10 chocolates, just take one chocolate. So one chocolate has been taken from our basket. Or else, because we don't have 10 chocolates or the chocolates are 0, no chocolates left. So for example, we write something like stash anything. Then we take the secret stash just like this. So we can just copy this and we run so that we explain it further. Encapsulation.py. First order, we run the code. One chocolate has been taken. Cool. So what if the chocolates are 0? Then say no chocolates left. So yeah, so let's explain what's happening again here. Let me just hide that. The secret stash class, okay? We create, this is just like example. This is just like, we said when we use a double underscore and we use the method in it, we create the sense of belonging. So self.chocolates. You see here, there's something that we have not done. In the previous ones, we could create something like chocolate variable right here. We could have done this in the previous examples, but this is encapsulation, so we don't need this for now. We can just save dot double underscore chocolate just to initialize this one here. So this one, we have created the private attribute of chocolates and we have initialized it right here. So we take a chocolate, we just define a normal function, chocolate and self. We said self again, it will help us access the attributes or instances of this class secret stash. So if the chocolates are greater than 0, then -1 chocolate from that basket. Then you can say 1 chocolate has been taken. Or else if we don't have more than 1 chocolate, just say no chocolates left. We define a variable stash, then we assign it to this secret stash. Then stash dot execute the function that is take chocolate. And that's where we get this 1 chocolate has been taken. As simple as it looks. And this one can be used in supermarkets. Wow. Someone is saying they are lost. Someone is saying they are lost. How do we tell them? How do we tell them? Someone saying they are totally lost. It's day 1 of learning OP. What do we tell them? We tell them no pressure, it's okay. We tell them no pressure, calm down. We tell them don't worry, it's day 1. It's day 1 of encapsulation. It won't make sense. It's day 1 of encapsulation. It won't make sense. But with time, it keeps on making sense. it keeps on becoming easy. We just tell them, come and redo it. Yeah, I see you guys have already mastered this craft. You don't give up. We just don't give up. We want to be programmers, of course, we have to go that hard way. You should not be worried. You have free time. At your free time, just visit an Indian guy. I see what you did there. Ah, like Doug Hodor say, don't worry, we have Evans here. Yeah, I'm going to return to the code. I'm going to return to the code. But imagine that marks the end of our session. But before I return to the code, that marks the end of our first session. You can join the second session. You're just going to do the same. Imagine if you attend the first session, then you attend the second session, the third session. It's just an example. I've not told you to attend. First session didn't make sense. Second session creating some sense. Third session creating more sense. Just an example. That's how life works. The first time you don't get it. And we said we are not giving up. Anyway, back to the code, stop the recording to keep it.